Hey everybody, we're going to divide some exponents. We're going to divide some radicals, okay? And so we're just going to get straight into it. Just like we did multiplying, we keep our outies separate and we keep our innies separate. We never mix our outies and our innies. I'll show you as we go on and do these. Let's take a look at this. They're both innies. If they're both innies, you just say, well, what's 10 divided by 5? Well, the answer is 2, but it stays in innie. If you have two innies, it stays in innie. They all stay inside, okay? So that's if it divides in. What if it looks like a fraction with the 1 on top? You can reduce. What if that was just 2 over 8? You would just write 1 over 4, wouldn't you? Okay, but these have to stay in. Okay, so those are innies as well. But if you notice, I can do square root of 1, it's 1, and I can do square root of 4, it's 2. So that ends up being my answer, okay? So again, just reduce the fraction, but keep them inside, and then if there's something you can do after, do it. Okay, let's take a look at this other one right here. So now I have some outies and some innies. Well, let me ask you this. I'm gonna write the fraction sign below it. What is 6 divided by 3? I'm not worried about the 6 and the 10 or anything else. That's an outie, that's an innie, they don't touch. Okay, so 6 divided by 3, I'm left with a 2 on top, okay? The 3 just got divided into the 6. And this, the whole 10 is going to be gone. I'm going to be left with square root of 5. Everything on the bottom is gone, so I didn't really need the fraction line. And boom, there is my answer. Well, that's great, but there are some problems we can run into. Let me throw some up there for you. Okay, I wrote 3 on the board, and we're going to do something, it's a big fancy word, it's called rationalizing the denominator. Now, if you have a radical in the denominator, that's considered improper, okay? We don't want to leave anything there. You're going to be asked to give answers with no square roots in the denominator. Well, how do we get rid of that? Well, remember that one trick I showed you, where if we went a square root, I showed this in the previous video on multiplying, if I did square root of 7 times square root of 7, that's square root of 49, which is normal, everyday, 7. Okay, if you take a square root and multiply it by itself, you're going to end up getting just a number outside of the square root. So, to get rid of the square root of 7, I'm just going to multiply the bottom by square root of 7. Am I allowed to do that? Yes, as long as you do the top as well. Okay, because that actually ends up being like a 1. Square root of 7 over square root of 7 is going to be a 1. Okay? So, cool, let me get a little bit of room here by erasing this. And as I do that, what is 6 times square root of 7? It's 6 root 7. What is root 7 times root 7? 7. Done. Oh, but wait, I didn't cancel out these 7s, right? No. Why? Innie, outie. We don't touch innies and outies. Outies and outies? Cool. Innies and innies? Right on. Outies, innies? Nope. Innies, outies? Nope. Okay, so don't start canceling out innies and outies. Let's look at this one. I can just cancel out the 3 and the 5, correct? No. Innie, outie. They can't touch. Okay, and I apologize. That actually I can, because I wrote the problem wrong. That was supposed to be a square root of 15. So the first thing I'm going to do is I'm going to do my innies, and I'm going to go ahead and deal with that. And I'm going to get 4, the 3 cancels out, and I'm left with a root 5 on the bottom. So I was able to deal with my innies beforehand, okay? Now that I've done that, I'm just going to multiply each side by a root 5 over a root 5, and that's going to give me a 4 root 5. 4 times root 5 is 4 root 5 over 5. Can I cancel out my 5s? Nope. Because one's an innie and one's an outie. Okay? Let's do this one. All right, well, there's nothing that can cancel out or do anything, so what do? What's the problem? The problem is that square root of 2. So do I multiply by 2 square root of 2 or just square root of 2? 2's not a problem, he's fine. It's the square root of 2 that's the problem. So I'm going to square root, I'm going to multiply by square root of 2, square root of 2. And that's going to give me what? 5 square root of 14. Remember, we just multiply the innies. We don't have a mix with the outies. And this one, now, I think I'm going to write it like this. I just wrote that 2 right there. He's there. Now I'm gonna do square root of 2 times square root of 2 equals normal everyday 2. All right, so I have that 2, and I have the 2 when I multiply them together. When I put it together, I'm gonna get a 5 root 14 over 4. Now, the next thing you should do is see if that 14 will break down. It's 7 times 2, it won't break down, so I'm done. All right, so rationalizing the denominator, that's an example right there. And then we have this right here. There's also a thing called a conjugate square. That's going to be another video because that's going to take a little while to explain. But this is it. This is dividing. So now you know how to add, you know how to subtract, you know how to multiply, you know how to divide, you know how to simplify, you know how to deal with fractional exponents. We've done that all in this chapter. The one thing we haven't done yet is we haven't solved for these yet. So let's do some problems and solve for them. That's the next video. See you guys there.